Find the dimensions and units of the following. For A, we have acceleration. For B, we have power. Take down solution. Question A, we have to find the dimensions and units of acceleration. We know acceleration is simply equal to the rate of change of velocity. Is simply equal to velocity all over the time. It simply means if we have to find the dimensions of acceleration, it will simply be equal to the dimensions of velocity all over the dimensions of time. Getting the dimensions of acceleration, that means we have to express acceleration in terms of the basic fundamental quantities. These will simply be equal to velocity. We need to get the dimensions of velocity first, then we divide by the dimension of time. Velocity is equal to take a displacement all over the time taken. It simply means the dimensions of velocity will simply be equal to the dimension of displacement all over the dimension of time, and this will simply be equal to the dimension of displacement is simply L all over the dimension of time, which is t in brackets like this. This will simply be equal to L times t raised to the power -1. We make use of this property. We know 1 over a is simply equal to a raised to the power -1. It gives us this. This is the dimension of velocity. We are going to insert it here. We divide by the dimension of time, which is t. This will simply give us the dimension of acceleration to be equal to, we replace velocity by the dimension of velocity, L times t raised to the power -1. We divide by the dimension of velocity, which is t. This will simply be equal to L times t raised to the power -1 times t raised to the power -1. This will simply be equal to L times t raised to the power -1 plus -1 gives us -2. This is the dimension of acceleration. Next, we have to write down the units of acceleration. The unit of acceleration is, the unit for length is the meters. We replace with the meters. The unit for time is the seconds. We put the power, which is -2. The unit of acceleration is meters per second squared. You underline the result. Move now to question B. For question B, we have to find the dimensions and units of power. Power is simply equal to the rate at which work is being done, means work all over time. Next, work is simply equal to force times distance or displacement. It gives you the work done. First, we need to start by determining the dimensions of work, then before proceeding to determine the dimension of power. Work is equal to, we know force is the same as the mass times the acceleration times the distance covered or the displacement. It simply means the dimension of work will simply be equal to take the dimension of mass times the dimension of acceleration times the dimension of distance. This will give us the dimension of mass, which is simply m times the dimension of acceleration, which is this L times t all this raised to the power negative 2 times the dimension of distance, which is L. This will simply be equal to multiplying all this. This will give us n. L times L gives us L squared times t raised to the power negative 2. We are going to replace work, the dimension of work, with this m L squared t to the power negative 2. Then we divide by the dimension of time to get the dimension of power. The dimension of power, which is simply equal to the dimension of work divided by the dimension of time. This will simply be equal to the dimension of work, which is m times L squared times t raised to the power negative 2. We divide by the dimension of time, which is t. This will simply be equal to m times L squared times t raised to the power negative 2 times, bringing this up, it gives us times t raised to the power negative 1. This will simply be equal to m times L squared times t raised to the power negative 2 plus negative 1, which gives us negative 3. We underline the dimension of power. Next, we have to write down the unit of power. The unit of power is, we replace m with the unit of mass, which is kilogram. We replace L with the unit of length, which is meters squared. Lastly, we replace T with the unit of time, which is second to the power negative 3. Therefore, the unit of power is kilograms, meters squared, seconds to the power negative 3. You underline the unit. We are done with the solution of the following questions. If in case you have any doubts, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.